understanding the technology that powers the money is essential. Knowing the business drivers that inspire how the money is made is crucial. Bridging the gap between the mind of the technologist and the mind of the business is monumental. That is what TBF is all about. Let's start this never-ending conversation. It's time.
We are back with another episode of the Tech Behind FinTech. I am so excited about today's show. We're going to talk about AI model security. Joining me is the co-founder and president of Protect AI, Daryan Dehghanpisheh, otherwise known as D. D, welcome to our show.
Thank you, Ned. It's a pleasure to be here and an honor to be here with you and the audience. Thanks for having me on.
No worries at all. So, let's do some housekeeping stuff. Then we're going to dive into it. We are streaming live from Facebook, LinkedIn, and YouTube.
Awesome.
Today's episode, extremely excited about it. I met D at a Finos conference, an open source conference, hit it off. I love what they're doing to protect AI. It's something that I've been interested in terms of my research in academia and things of that nature in terms of ML security. I was curious as to, we're building all these AI applications. It's pretty much ubiquitous. A company that is, that's what they specialize in. They have all these tools, a great community. So without further ado, let me introduce my guest and then let's get into it. Let me read Deed's bio so you can get to know him, and we're going to ask him a ton of questions and learn more about MLSecOps. So D, prior to founding Protect AI, D led the global AI ML solution architects team at AWS, driving the growth of the world's largest AI ML business. Before Amazon, he was a senior VP of digital strategy at Howard Hughes Corporation, where he developed a groundbreaking AI platform for pricing and modeling illiquid assets in 2015. Earlier roles include Senior VP and Managing Director of Technology and Data Product at NYSE, the New York Stock Exchange, where he was part of the integration team during his acquisition by ICE, and 12 years at Intel, where he built the financial services vertical, drove over $1 billion in annual revenue, and served as chief of staff to the global sales and marketing organization. That's an amazing bio, D. Just want to make
Thanks,
sure
man.
We're still up.
Yeah.
Do you hear me clearly?
I think there's.
All right, cool.
You're having a little bit of jitter on the internet.
Let's get into it.
Okay.
Yeah, it's been an interesting morning with that. So I'm happy that hopefully all that is resolved right now and we can get back to it. So, for the audience right now, what is MLSecOps, D?
It's basically the evolution of DevSecOps to artificial intelligence applications, right? If your audience is familiar with DevOps and then DevSecOps, which essentially builds security into every one of the lifecycle stages of DevOps, the equivalent for that is MLSecOps, right? MLOps has been around for a long time, well over a decade. And essentially, that's just the process and methodology and the tools that are used to take essentially something from idea and concept into a machine learning model, which is really what separates the class of AI software systems from every other type. I think that there's a lot of hype in the industry and a lot of gamesmanship, for lack of a better term, around what is AI? What's the difference? And it's so different than every other type. It's really not. It's a software system, just like every other software system. And the only real key difference is that it's powered by a machine learning model. Whether that machine learning model is provided to you by a commercial provider, Microsoft, OpenAI, AWS, Bedrock models, whether it's open source, which is the majority of artificial intelligence applications in the world, where it comes from Hugging Face, great partner of Protect AI, and you're taking those open source assets and kind of using them to springboard and advance your development of artificial intelligence applications, or whether it's an internal data science team that has developed all kinds of models that they then want to put into a machine learning model to power a new type of artificial intelligence capability. ML ops is essentially that process. And what we noticed from our time at AWS, Oracle, all the founders of the company and all of the engineering staff have deep experience in cyber and in AI. And that gives us an advantage in understanding kind of where the seams are in terms of how AI is built, how those machine learning models are built, and the traditional security frameworks, the traditional security tools, and the methodologies that are there. There's a gap. And so we saw that gap. We created a company to do that. But creating a company is not enough. If you're going to secure an entire industry, you have to bring the industry along. And our way in doing that was to take DevSecOps, apply it to ML, and the most obvious thing was MLSecOps, right? Like, we're a pretty simple branded company. Protect AI. I wonder what we do. We protect AI. We secure it. And so MLSecOps is just basically the next evolution of how to build artificial intelligence securely, safely, and in a very like regulated, governed way. And when I say regulated, I don't just mean like government. I mean the way in which enterprises need to build software to keep it safe and secure.
Do you, and then on that note, right? Because I feel the industry from an application development perspective, everyone's talking about shift left, DevSecOps, but a lot of teams are not even fully mature in their DevSecOps practice. So now, you know, those same teams are developing AI applications. What are some of the challenges that you've seen in bringing the industry along, as you just mentioned?
Well, I think the biggest challenge in the industry is actually understanding what a machine learning model actually is and why it's important from a security perspective. And in our worldview, the machine learning model is just a new type of asset that's in your infrastructure. So again, if AI is a software system and you have lots of software systems in your environment, they have different assets, right? Those assets have different characteristics, and we understand that. And if you were to draw a comparison, and this was the conversation you and I were having at Finos in New York, which was, hey, if AI is reliant on ML and those machine learning models then are a new asset in your infrastructure, think of that the same way you would think about any other asset. And one that we all understand is endpoints, whether it's phones, laptops, whatever the case may be. We know that our enterprise security organizations can scan the environment, scan the network, and say, show me every MacBook Pro 14. And it will highlight that. The MacBook Pro 14 is in this office, or it's on this VPN. It contains its operating system, these files, has these permissions. I see what web traffic you've surfed. I know what applications are on there. I can inventory it, patch management, take it offline, tell your manager what you're doing or not doing. There's all kinds of things that I can do that. And I can do that with the click of a button, right? But you can't do that with machine learning models, which means you have assets in your enterprise all over the place, and you have no idea where they are. You have no idea who's responsible for them. You have no idea what they do or what they contain. And what's interesting about that versus those endpoints that I was talking about, those devices, is that a machine learning model, it self-executes by design. The minute you start to open it up, it does things, right? The minute you activate it, it engages. It has, in our worldview, remote code execution as a feature, not a flaw, right? And so the three things that people need to understand is that if you want to make a meaningful step in the improvement of the security and safety of your artificial intelligence software systems, it starts by securing your machine learning models. And that means that first, you have to understand where they are. Second, you have to scan them, just like we would anything else. There are more scanners in the enterprise that scan PDF files, executables, etc. Then there are things that actually scan all these ML files that go and get distributed all over the environment. And then the third thing you need to do is once you've scanned them, you need to maintain that security posture throughout its life cycle. And in Gen AI in particular, a lot of people really care about how that model is used with an application and how it changes as users engage with that machine learning model, right? So those are kind of the three things you need to do. One, you need to know where they are. Two, you need to start scanning them. And three, you need to maintain the security perimeter, if you will, essentially when that asset is actually being deployed.
I mean, that's really interesting. I love the analogy in looking at the ML model as an asset like you would any endpoint, because we have so many different tools, open source tools like Zap, in which you can scan your web endpoint, your API endpoints and stuff like that. But the concept now of scanning your model, right? A lot of people not on it. And I know that from a Protect AI side, because like I said, I'm into it. I know that you guys have an open source model scanning tool.
We do, but we also have a commercial scanner. We're big believers in, code settles all debate, right? And so when we first came on the industry, people were like, security of AI is not a thing. And we decided to prove it. We decided to make it a thing. And by releasing the industry's first and best open source model scanning capability beyond just like the pickle scanner formats, it highlighted to the industry that there's a need, right, for this. And as those open source endpoints or machine learning models rapidly grew and rapidly get consumed, I mean, there's over 1.3 million models on Hugging Face right now. And that's just the model. That doesn't include all the files that are in a model, right? Like we are the commercial scanner of that, not our open source tool, our commercial tool. So we have an open source capability. We have open source tools, but they're, as we would say, like an inch deep and maybe 2 inches wide versus a mile deep in capabilities and 10 miles wide in terms of enterprise features that are needed in our commercial model scanning tool called Guardian. And that is actually what powers the massive improvement in security and safety that Hugging Face, the world's largest repository for model files by far, it's essentially the GitHub of AI. Or as I like to tell my mom and others, it's essentially the app store for AI developers. Of how to think about that. And we are the only commercial provider right now on Hugging Face. We're very proud of that partnership, and we're providing new levels of security on the model files themselves. So it's not just what we have in open source, but again, it all comes down to what's the most basic thing we can do to build more secure, safe AI and do secure by design concepts into AI development. Scan the code. Scan the models, right? And so that's what we do. It's one of the things we do.
No, I mean, really, really good point, right? And I want to dive into that. For an organization who's never scanned their models, so I know a lot of organizations have not even breached this. Some are like really trying to establish a practice around it, or even I'll take it a step further from organizations I've talked to, they don't even know to do it. They know about DevSecOps.
Or why. They don't understand why they should.
Yeah. So, so it's that educational piece. Can you tell a story of a time when maybe it's an organization that you're working with or prospecting in which you scanned the models and it was like an oh, wow moment? Like I didn't know.
Yeah. Yeah. So what's really interesting is that there's two ways to think about the threats, right? One is, and you have to understand, going back to what does a model do, right? And what does it contain? Well, we said it's self-executing, which means it has a bunch of its own files. It has a bunch of its own file formats. It has a bunch of things in serialized code that is designed to execute when that model is activated. And so you have to understand the construction of that and what it contains. So there's two ways to understand the real threats. And the first way is like, hey, these are perfect vectors for outside threat actors to leverage as a way to implant backdoor code or to implant things that would be malicious and undetected or undetectable. Because when you think about traditional security mindsets, what do we worry about? We worry about people breaking in, coming through the firewall or coming into the environment and stealing stuff. What's interesting about a model is that model is already on the other side of the perimeter. So when that model is activated or does something, it breaks a hole out of your firewall, out of your network, right? And so once I've got the ability to bust a hole into that perimeter and traffic things out, that model can leak traffic, can scan your environment, can do all kinds of crazy things because I'm already trusted in the environment. And then when I blow a hole out of that perimeter, it looks like regular port 443 traffic that you can't identify. Like, it just looks like normal traffic going out. So you don't know what it is. So one of the most common things that we have seen is that the backdoor codes link to and make a call out to some unprotected random cloud bucket, like an S3 bucket somewhere, right? An open one that might be empty right now, and it's constantly polling, as an example. Those are things that you should not be doing. The other things that model files that we're seeing from the outside do is we see a lot of like get attribution commands or run executables. Like, they essentially hijack the data scientist who has higher rights, roles, and privileges, basically attack the credentials on that, get the credentials, and then do kind of the credential shuffle across the network internally to find the resources they want to then do whatever the malicious code is. That's the most common thing that we see. But there's an evolving new type of threat, and that is the insider threat. It is a perfect opportunity for industrial espionage to have those model files be easily corrupted. And if you go Google this or go search it in Perplexity or anything, you'll find that what you're going to see is the ByteDance organization, which parent company of TikTok, is suing one of their developers who planted malicious code in a machine learning model and caused them tens of millions of dollars of damage. Right. And so that's out there right now. That happened. I think that case was filed a couple of weeks ago. But if you go Google it, and we can put it in the show notes for you and deliver it if anybody is interested. But the insider threat becomes really important because industrial espionage is a thing. And if you talk to the leading financial services companies, they always worry about insider threats. Right. Well, a model is a perfect place to hang out. So once I brought a model in, go back to the laptop. When your IT organization gives you a device, it's pristine, right?
Yeah.
It's clean. Then you start surfing the internet. Then you start doing things, and it gets corrupted. It gets tainted, not through any malicious act, right? But you could also do things on that device that could cause problems later. Right. So whether it's Capital One and kind of the rogue employee that leaked all the data on AWS, or former AWS employee, or whether it's some of the other firms where we've seen these in the headlines where it's the inside actor, machine learning models are really cool ways for people to hide out in and do nefarious things. And there's not a piece of capital that moves around in the bank or in a financial institution at all that doesn't touch at least a few machine learning models. It's not just about the Gen AI side. It's about all the things that machine learning does and has been doing for finance institutions for over a decade.
Wow. So that's a really the insider threat. It's so funny because years ago in my grad program, I had an FBI professor. We were talking about that. He was like, the majority of cybersecurity cases, it's whether someone unknowingly does something or knowingly does something malicious. Majority is insider threat. And this is just not having to do with MLSecOpts, just cybersecurity in general. So it's interesting that you said that. In looking at, when we start relating it back to DevSecOps and we start looking at the software development lifecycle, how can an organization get started in this practice, right? Because we look at the when you start looking at the SDLC and looking at how to build this stuff, the first thing, my experience, is threat modeling, right?
Yeah.
So, we start saying, okay, here's what we are trying to build. Here are other things. What are the potential threats in some of these requirements? Adding it to the backlog and so forth. Can you describe the cycle?
Yeah, sure. So if you think about DevSecOps, right, and you think about the steps that are used, when you think about DevSecOps, you've got the plan, code, build, test, release, deploy, operate, monitor, like infinity loop that many people are familiar with, right? And in each one of those steps, we're doing security things. So it's planning, you're doing what are the security requirements? What is the threat modeling look like? What are the secure coding practices we're going to implement, as an example? And when you go all the way out to deployment, you're thinking about things, simple things like auditing and threat intelligence feeds. When it's into the release stage, you think about things like digital signing or compliance validation, right? Like we know what those steps are in DevSecOps. The interesting thing is that 90% of what you're doing on DevSecOps or DevOps, or even your standard, like just say SecOps, even if it's not DevSecOps, just security operations, right? 90% of what the firms are doing is still applicable. You need to still do that. It's that last 10% that you need to think through. So when you talk about things like implementing threat modeling, it's not necessarily doing something new. It's about having the right tools for the job, because traditional tools in those processes don't do enough. As an example, how many scanners how many scanners have been in enterprises in the banks for, I don't know, last several decades? Many. They don't just have one, they have all kinds of malware scanners. Ask yourself why none of the malware scanners have been scanning ML models. Because they don't understand it. They don't know what to look for, right? And they don't understand why a certain call should never be in a model file. Might be perfectly acceptable in another type of code, but it should never be in a model file. So when we talk about threat modeling and you talk about policy considerations around what you want the AI system to do or not do, how you want it to behave, when you talk about, SCA and SaaS DAST kind of capabilities, you invoke those things with the right tools so that you have understanding on the new types of threats, on the new types of assets, the machine learning models, and the new types of monitoring and management and governance, observability, all the other things that you would do, right? So generally, we say, hey, start by securing the model. What does that mean? Well, if you're building model files themselves, scan them. If you're sourcing them from the outside, scan them. If you are allowing people to modify them internally, scan them frequently and maintain that security posture, right? But then when you put it into deployment, you've got to now start thinking about it from an offensive penetration testing or red teaming type of methodology. Now, we're familiar, as an example, very familiar with what red teaming and pen testing is. We get that, right? But here's the thing. Most pen tests and red teams are done for one of three reasons. It's either part of the software development lifecycle, right? You're doing that and making the check before you release something. So it's part of a release cycle, or it's part of your incident response management, right? Or it's related to some regulatory and compliance action that has to be taken. The challenge with AI, though, is that those models kind of self-modify and they start to learn things. They do things differently, particularly with generative AI is what I'm talking about. So when you have a generative AI application, generative AI red teaming is very, very different. And you can't wait, because once that LLM model, right, once that model starts misbehaving or doing things you don't want it to do, you better be alerted and you better figure out very quickly why. You can't wait for something. So it has to be much more automated. It needs to have much more frequency. And that means that you have to be monitoring, managing, and observing the traffic between the human and the application, which is powered by the model. That's a very tight thing that you need to constantly observe. You need to firewall it, sure, but you also need to manage it, and you need full context on those things. It's not just a state management, like a state change that happens at that perimeter. It's really the full context, right? And so while we started on model scanning, now what I'm talking about is once that model's in production and in deployment, you have to start thinking about your traditional offensive security practices. What are you doing to augment those practices for generative AI applications? And for those same things, what are your kind of observability tools, your management tools, your logging capabilities? What's happening at the perimeter where people are actually engaging with those applications, right? Because again, if you think of it as a new type of endpoint, you need to be monitoring that, right? And so those are the things that you need to be doing. Just like off the base, right? Scan the models, implement Gen AI red teaming capabilities, and put observability and management capabilities on those endpoints where generative AI is being done today.
I think your point's taken. I think like if you think about it like an endpoint, you would do everything to secure it as you do your current endpoints.
Exactly.
If you look at it from that standpoint, it simplifies a lot of the complexities. Now, obviously, you have to look at another layer of how does this, anything that you want to secure, you have to understand how it works. So then you have to, okay, how does this model work? What are the security practices within it? But if you think about it from that standpoint as an endpoint, then yeah, it also helps you understand gaps, because why aren't you doing this? Like, why don't you have some sort of observability within this particular endpoint as you do your others, right? Why can't you see what's going on with it on a consistent basis? Why don't you know if there's some type of malware, some type of vulnerability?
Exactly.
So it's like really asking yourself these questions. And if you don't, okay, what tools or processes do I need to implement in order to do that? Like, since we've met, I see. Let's always put comments out. We have the MLSecOps community giving us a high five. So thanks, guys. I've joined I know you guys have started the MLSecOps community. I respect what you guys are doing, because you have the enterprise level, but you also have like the open source and level to bring, like you said, the industry along with a lot of education. I want to touch on that. I've been watching your podcast as well, your MLSecOps podcast. Let's talk about, I saw a video you did on we're talking about S-bombs. So in general, industry knows about S-bombs. So those that don't know, software bill of materials, give you an overview. If you were to buy a car comes in, there is a list of items and different vendors and resources and different things that were used to make that car. Because you have to know this stuff, because if something goes wrong with it, you basically need to know, okay, where did I get this from? What vendor? Every manufacturer has a bill of materials for each vehicle. So if we look at it from that standpoint, from software that we build, not talking about ML, just software, you have a standard bill of materials. Like what libraries are you importing? How is this software composed, right? What are all of the various libraries and things you use to create this software, especially the fact that open source is ubiquitous. Everyone uses it from enterprise level to build some stuff. So you have to know that, because if one of those components are vulnerable or you haven't updated it, it's a potential issue on the security side. Can you now talk about, I saw your video, the AI bill of materials?
Yeah. Sure. And I think you hit it, right? Like, we're familiar with what a software bill of materials are and is, like SBOM, right? And there's two primary standards there. There's SPDX and Cyclone DX. And then, of course, large institutions have their own software bill of materials capabilities, management, like they think about all the composition of an application. What's interesting about an AI application is that the provenance of software bill of materials, the provenance of software, the provenance of code, or the provenance of data is actually not built for the provenance of artificial intelligence systems, because it misses the middle layer. We like to have this diagram, and if you've seen our presentations in the past, it's, you can go see them on public. We have this notion of, here's your data pipeline, it feeds into your MLOps pipeline, which feeds into and creates that model. That model then goes into your code pipeline, right? If you think about them as separate things, what people are not doing is actually doing the MLOps kind of bill of material, and thus the model, which is the asset that's producing, it has its own associated bill of materials. What is the packaging type that was used? What data set did it train on? What data set was it authorized to train on? What were all of the things that went into that? And where is that model powering other applications? You can have one model that's powering many, many applications. You can have many versions of models powering different versions of those same applications. So now you're kind of, your dev versus prod type of philosophy becomes very, very fragmented, very, very broken, very, very quickly. And as a result, you kind of have to manage those things in almost like bitemporal but parallel nature. You have to constantly be versioning all of the changes in the system and matching those up, right? And that's how we think about the AI bill of materials at its most granular level. But that's actually not even the thing you need to worry about the most. We talked to tons of customers, lots of partners, government bodies, researchers, and everybody goes to what I would call the blade of grass problem. And to me, and by that I mean like, oh, they want to know the model card. What is the performance? What is this? What is that? It's like, that's not really what we're talking about. What we're really trying to get a sense of is the provenance of that AI system, which means where are all the data assets? What were they trained on? What is the model? What is the latest security state of that model? What are the things that are incorporated in that model? And what are the applications it's powering, right? And so if you think about it in that construct and you lift up the level of abstraction, what you really, really need to understand is where are the models, what are the applications they power, and who's responsible for them. And if you start with that basic understanding and cataloging those basic things, you can create security policies around those. You can create security policies around what is or is not acceptable from a security standard perspective on the model. What is or is not acceptable for the model to do in its output. What is or is not acceptable for an input. Like we watch employees surf the web all the time, right? We need to start thinking about watching what they're asking the internal agents for very prescriptive reasons. So again, you kind of need to think through an AI bill of materials as, okay, how do I aggregate the things in the data sources, the things associated with the model itself, and then the things associated with the applications that are reliant upon those two. If you think about them in those three capacities, how you mix and match those or how you catalog them is up to a lot of different industries. Now, and up to different players in those industries. Like Citi is going to do it different than JP is going to do it different than Goldman's going to do it different than, Bridgewater or any of the buy side firms. There's going to be a whole host of different philosophies on what matters and what's important. But at its fundamental level, it's understanding the data sets, understanding the models, and understanding the applications that those two feed into.
Wow. No, it's very interesting because, as we talk, I just know of organizations that just this exercise is totally foreign to them.
Well, it's probably not. They're just not doing it in the AI applications, right? And this is what happened. Like we're probably old enough to recall when people were walking around going, "I need an app for that," right? I need an app for that. And they'd be like, "What for?" I don't know. I just know I need an app. And that's what's happened with AI. What's happened with AI is like, I need a chat for that. I need a bot for that. I need a model for that. It's like, cool. They're not even asking about the security stuff.
Yeah.
And if you go back into the mobile race, what happened? Everybody who said, I need an app for that, the IT teams are like, yeah, we don't know how to get there yet. What'd they do? They didn't wait.
No.
They went and got agencies. They went and got Adobe stacks. They went and got all these new, IT stacks and offerings that went out. They put a bunch of stuff out. And then all of a sudden, a consumer credit card breach happens. It's like, well, how did that happen? The IT team says, I don't know. It wasn't our thing. It was over here. There are AI stacks all over the place inside of an enterprise that are escaping traditional security, traditional governance, and traditional regulatory components, right? And so that's a problem. As you get your arms around that, what happens? People do, like as an example, they're familiar with their software bill of materials processes or their software composition processes and the versioning of those things, right? They're familiar with that. What they're not doing is thinking about how to apply that to the AI environment. And they need to. It's a very familiar pattern. Just take what you're doing here, apply it to AI, but make sure you have the right tools for the job, right?
Looked at one of your previous podcasts. I really enjoyed it. You had someone on from MITRE, and we know about the cybersecurity kill chain and stuff like that. And they had something called Atlas. I have a screenshot. I'd like to put that up, and maybe we could talk through that.
Sure.
So it was hold up. I really enjoyed the that particular podcast episode, because it's similar to what we've seen MITA do before with their other chart that we use.
Mm-hmm.
And looking at the Atlas mainly. So we still have reconnaissance, right?
Mm-hmm.
And we still have, but it's now particularly, it's everything's related to an ML attack and techniques.
Mm-hmm.
Can you just walk us through some of these points?
Well, again, I think when you look at some of the new ones, some of the things that are in here are familiar constructs in the attack framework. So let's step back for a second. I think what you're referencing is actually Dr. Christina Liagatti, who is a friend and wonderful person. I encourage everybody, if you want to know about AI ML security, reach out to her and reach out to us, of course, but she's a great resource. But what MITRE has done really well in other constructs is the attack framework. That created a standard way of thinking about security of software and security of networks and systems. What they realized was that there are differences in the AI systems, and as a result, they kind of took the best of attack, their attack framework, and kept what they thought was relevant and started adding new things in there. So if you were to map the two side by side, there's a lot of similarities, right? But there are certain things in there that are very similar, like, for example, under initial access, where it says ML supply chain compromise. That's essentially like an LFI, RFI type of attack that might happen in the software supply chain. It's no different than necessarily what you would do in any other space. But then there's things like LLM prompt injections, right? And how that LLM prompt injection or the backdoor ML model, where those things can be triggered later. They can lay in wait, or they can not necessarily lay in wait, but purposely kind of be around for someone to activate that model. Because again, what does a model do? It self-activates, right? So if I give it a certain instruction and that in certain phrase of, abracadabra 1 2 3 4 5 or whatever it is a secret phrase to that LLM model, it is possible that LLM model can then invoke all kinds of things and do all kinds of things that it shouldn't be doing that would be considered harmful. So that's kind of how we think about the attack framework relative to Atlas, is that we really focus on the differences there. So supply chain components, LLM prompt injections, backdoor model issues, adversarial data components is not something we do, but you'll see other firms doing things in that space. Proxy ML models. And the most interesting thing about that is that, like, some of the most efficient, effective ways of breaching an AI environment is actually through hijacking the data scientist credentials through models, right? And so that's essentially the most common pathway that we see. Two of our researchers, they give a really great talk called "I Hunt AI Engineers." And what it is it's a way in which they use traditional hacking methods on AI assets that go then undetected, right? And the best way to do that is to breach the credentials or hijack the credentials of the data scientists, because classic web developers have pretty isolated privileges, rights, and roles. But data scientists typically have the highest rights, roles, and privileges in a company because they have to have more access to more live data environments. So that imbalance creates all kinds of crazy things. But the MITRE Atlas framework is really, really important. It's really, really useful. It was one of the earliest frameworks to think about AI security, but there's been a whole slew of new ones that have kind of drafted on that. And there are some that are really, really prescriptive. The NSA publicly released their version of how to do that. You can Google it and we can provide you the show notes for that one. We're big fans of that. You see a lot of vendors doing this as well. So Databricks, another partner of ours, has a really great security of AI framework for their products. And what's interesting is they give very prescriptive guidance on what you need to be doing at every development step. We're honored to be in that with them. You see that with Snowflake, again, another partner of ours, where we're also working very heavily with that. You see it now with ServiceNow. You see across the board, like, the big enterprise software providers are giving their perspective on what those AI security frameworks are. And there are differences, right? So MITRE did a good job at getting out ahead of the industry and really saying, hey, we need to be thinking about this in a thoughtful way. And hats off to Dr. Liagotti's team for that. They've done a great job. But now you see things like the NIST standard. Again, Martin Stanley, a guest on the MLSecOps podcast with Charlie McCarthy from our company. Others, like it's really cool to see what they've done on the NIST AI risk management framework, right? You're also seeing things like IEEE has their standards now. You've got the ISO 40001 standard. You've got a bunch of things that are now coming on board. But MITRE kind of was the early runner in that.
Got it. Thanks for that. Want to talk about, so, you know, I know when we met, you have the blue team aspects, the MLSecOps community. You also have a red team aspect to protect AI. Can you talk about that?
Yeah, we're very happy with that. It's honestly, it's an amazing thing, which is called Hunter, HUNTR.com, purposely misspelled. If you go to hunter.com, what you'll see is that it's the world's largest AIML bug bounty program. And we initially went down that path to prove to the industry that the supply chain that everybody was relying on is hugely vulnerable and was not being detected by people within the security tools landscape, right? Like you might get a CVE on something, but the network scanners inside of the security tools of most of these enterprises weren't scanning for the most common tools like MLflow, which is used all over the place, or Trident Inference Server from NVIDIA, like open source capabilities, really important tools. They just weren't being like cataloged. But since then, what we've done, especially with our great Hugging Face partnership, is we've essentially pivoted that towards machine learning models as well. So now security researchers, hackers, can get involved, get paid for showing how a model can be corrupted and can evade traditional security mechanisms. We take insights from that community. We pay out great bounties. So I encourage anybody who wants to learn more, like go check out hunter.com, start learning how to hack a model. We pay very quickly, but that gets incorporated into our scanners, and that gives a new level of security capability throughout. And if you want to understand how those things work, go to protectai.com/insights. And what you'll see is our updated daily threat library of models that we know to be vulnerable. And that doesn't include all the ones that we have figured out and have an issue, right? Like we are very, very good at understanding the breadth and depth of where security vulnerabilities in machine learning models lay today.
Brilliant. D, you're one of the guests that I would just like to spend all day and talk to about this, because I'm just absorbing it all in. Like I said, this is something I've been fascinated. I have a background in DevSecOps and AppSec security, so I was always thinking through for the last year, like, okay, the transition will be ML security. Like, how are we securing this stuff? What are we looking at? And then, when we had our conversation a few months ago at Finos, I was like, yeah, this is exactly what I've been thinking. So definitely want to start looking more into it. And I noticed that on your side, let me pull it up, you guys even have an MLSecOps certification.
That's right.
Talk about that.
Yeah, it's great. We did this at the request of one of our customers, who actually is one of the largest banks in the world. And the request from the security team was, hey, how do we get security practitioners and machine learning practitioners to understand the basic 101 concepts of how to do secure by design for AI? We said, sure, that's a great opportunity. So the course is free for everybody to get certified, but what it does is it provides a base level knowledge of what MLSecOps is. It's free. Go take it. It's taught by Diana Kelly, one of the best CISOs in the industry, period, and the best CISO in the AI security industry, bar none. And she speaks all over the world. She was just at Black Hat MEA. She's fantastic. But when you take that class, what it teaches you is kind of what MLSecOps is and the easiest things to do that aren't necessarily dependent upon a particular tool. We obviously augment that, but it gives everyone who takes that course a basic understanding of both how AI security is different, and B, what types of things you need to be thinking about from a process and procedures capability to implement, so that C, the most important element of security, which is people, are actually brought to a certain bar, a certain level of knowledge on AI security. It's a wonderful course taught by Diana for free. I encourage every one of your viewers, listeners, however you're consuming this discussion today, go to protectai.com, click on that MLSecOps certification and take the course. It's free.
I actually listened to Diana's Black Hat speech on YouTube. I mean, she's brilliant. Definitely a fan of her work. D, like I said, I know I would be respectful of your time. I could go on and on. Keep asking questions and just pulling up random presentation screenshots. Hey, what's this? So, I definitely want to have you on again, man, and extend conversations on this topic. Something that's really, I think, is important. I think especially with the rush of, like you said, everyone's using some sort of model. Like, do you have an app for that? Do you have a model for that? Like, if you think about security for sure. What we do for our guests, we're going to give you a couple of minutes to talk about Protect AI and how people can find you and things that you're doing. And I'm going to get off stage and let you do that.
Yeah, well, thank you. Just go to protectai.com and start clicking around, look at the Insights database, check huntr.com, and engage with us on MLSecOps.com. Join that Slack channel. Tons of great events that we're doing both digitally and physically. We'll see you at all the major security conferences and all the major financial conferences. And of course, if you are an open source user, or a member of Finos or the Linux Foundation, you can find us there. We're a board member along with NVIDIA and some of the major banks. But yeah, it's a pleasure to be here, and thank you so much.
Thank you very much for your time today. Everyone, we are always live Friday, 12 p.m. We have a slew of some outstanding guests like D, and touching on different topics within FinTech and technology impacting FinTech. So our goal at Tech Behind FinTech is to demystify FinTech, both on the technology side and the business side. So you can join us live every Friday, 12 p.m. EST. Looking forward to, we have a real lineup into 2025 and next week and so forth. So definitely stay tuned with us. Like I always say, whether you're watching us live, whether you're watching us tomorrow, next year, we thank you very much for your viewership. On that note, we're out. D, I will be in touch definitely, and you have a great day and a great weekend.
You as well, my friend.
Cheers.
Cheers.
Understanding the technology that powers the money is essential. Knowing the business drivers that inspire how the money is made is crucial. Bridging the gap between the mind of the technologist and the mind of the business is monumental. That is what TBF is all about. Let's start this never-ending conversation. It's time.